Hello, you beautiful people. This is Uncle Code here, and I'm very excited because I want to explain a new feature added to Crawl4ai, and we call it URLSeeder. What URLSeeder does, it's a capability that let you to take a look at all the links exist under a domain before you jump and crawl them. So why this is important? What can do? But think about it. If you are in the business of data extractions, you understand that how valuable is this. Crawling or data extraction is a search algorithm, it's a search problem. We go to a page and extract links from one page, and then we have to go to every one of them and then extract other links and go deep and deep till there's not much links left in that domain. This process is time consuming. Yeah, sometimes we just want to extract everything and then later skip them in our database and do some sort of stuff. Sometimes you want to create data for fine-tuning, but not all the times. Many times you want real-time data for your agentic softwares. You want to find answers. You want to build a research assistant. That's what we're going to do now. And for those scenarios, you have a query from the user or you have a target, an objective, and you're facing with a website with 10,000s of links, for example, TechCrunch or Hacker News or this and that. So if there is a way that you can get all the links of the website, not just the links, information about those links, a little bit at least, that can help you to filter, it's magical. It's a perfect way to save money, times, and all these kind of things. It's perfect. And that's what it does, the URLSeeder. So it sets URL for the next round that you want to do the crawling. You will see here that in this new techniques that we added to the library, and it's fresh, and I assume it's going to be mature a couple of weeks, it gives you all the links under that domain, and it has some capability. First of all, can check those links are broken or not. It's perfect. And also has this extra ability that can extract the head section of every page, the information of because every HTML page has head, has body, head and body. And the information on the head means title, descriptions, metadata, social media channels information. They are perfect information that you can extract all of them rather than extracting the entire page. And then later, in your RAG systems, in your information retrieval systems, figure out what are the pages that you are interested to go deeper, and then go for the full page crawling. And I have to tell you something. When you want to extract only the head section of a page, you don't need Chromium. You don't need browser. It means it's going to be much cheaper, much faster. It doesn't need anything. Just quickly. And you can do it in parallel. You will see that I do 1,000 concurrency thanks to asynchronous I/O. So those are the things that we are releasing and bringing in, and these are going to be the new version. New version has some other crazy stuff, but right now I'm just going to focus on this one. It's still not out there. You can take this from the next branch, you can pull it down and you can play with it, but new release will be out just in a day or two, and then you can try it. So without further ado, let's jump and see how I'm going to create this research assistance. To build any agentic software, you're building a pipeline. You're building a process, a way of doing multiple tasks. And there are different ways. You know, when our brain is used to the linear way, I get the query, I search, I find the best, and I generate. So that's one very common way. But some of us can make it more complicated. Maybe we can bring reflection. Maybe after creating the informations, we let the pipeline to think about what already has created. If it's good enough, I continue. If not, I will back. So you see, you build an algorithm. It's just this. I know we love to use the term agent, but technically it's just this same algorithm, procedural algorithm, that this time LLM can make decisions among these steps. LLM can do jobs. So that's why it brings some little unpredictability in it. But the truth of matter is there are just different patterns of execution of a pipeline. In this example that we have here, the Colab that you can have access to, is there in the repository, is what we're going to do. We're going to get the user query, then we do the user enhancement, means not the user enhancement, query enhancement, means we get the query, make it better, we remove, clean it, some star words out to be something more suitable. And then we do the URL discovery. The URL discovery, the URLSeeder, has the capability to filter out URLs based on the given query. So that's really cool. And then we get the relevancy score for each one of them. And then now we can filter out. You can put threshold for the similarity. And finally, we have the final SID, the SID, the stem cell of or your research assistance. Then we do crawling for all of them. And then we have the informations, then we synthesize and we generate the report. So this is a linear way of creating an agentic pipeline for research assistance. So let's go through it. Let's see what we're going to have. So the very first step is we build, or let me reconnect. So what we're going to do, because this is not yet in the version in the PyP, so that's why I have to clone the next branch. Next is my favorite branch, is dev, is where I work. So interesting stuff, cool stuff you can find over there. And then, but anyway, it's going to be soon. And then you can just, perhaps by the time that you're trying this, the library is ready. And then, as usual, what we're going to do, we're going to run the Crawl4ai setup, and then we go and run Crawl4ai doctor. If in some weird situation something happened, I don't know why, I think because Colab is a Linux container, I think some of their container is not always the same. The version is different. I have such a kind of feeling. In that case, you run playwright install command, by yourself. Anyway, it's in the documentation. If you are following me, you already know it. And then what we're going to do is, okay, this is the usual yada yada import. So we just import the universe. These are just, you don't need to import rich library unless you want to be rich. It's good to be rich. But the point here is that I just want to make it a little bit colorful, nice, make you happy, make myself happy. So that's why I just import them. And then, okay, this is what I was talking about. Let's see. We don't need this actually. We don't need this as well. These things all can be there. So let me copy this one. Yeah, these all can be there. We don't need. Okay. And within this pipeline, I need large language model. So I use my favorite library like LLM, which allows you to get access to many LLM providers, cloud, local, Hugging Face, Olama, LLM Studio, OpenRotor, and then through the OpenRotor, you're connected to all the models in the cloud. So, and that's it. So the environment is ready. Now we go for the very first step. The very first step is, for this research app, I like to create some data classes. I like data classes. For example, let's say if you're creating this research assistance and there are some configuration to pass to the pipeline, I love to create config objects the same way that I did for Crawl4ai. It led you to really organize your data. So I'm creating a research config. You can do any other way, but this is my way. So one is a domain. If for this example, I want to pick up bbc.com/sport. I want to see whatever under this sport. And we have max URL discoveries. So there's a little explanation here in website documentation. Everything is there. It explained that how many URLs maximum that you want to discover, or how many URL maximum you want to crawl. Okay. I removed some of them because we don't need to see all the details. But anyway, the top K URLs means when we find cross-check with the given query, we have similarity, and then we pick up the top 10, for example, top 5. And then we have this score threshold, which is basically threshold that above that we consider relevance. If not, not good. And we have different scoring method. Right now is BM25, and I'm going to add soon embedding as well. But when you do embedding, you have to download the embedding model. But BM25 is there. I think it's good. And especially if you are not extracting the head information. So then let me ignore some of this. So some of these things, we can ignore it. Let me just ignore some of them. Okay. And then the LLM model is, okay, I will keep it. Okay. And then we have this LLM model. You can use anything, even I pick up the 4O mini because don't want to do magic. You want to synthesize them and generate the text because you have pure data. Or you can pick up any other model you like. And you see extract head metadata. It means that I want to extract the data sections. Or no, I don't want to do that. Depends on your scenario, your case. Anyway. And also another configuration that we have here is live check. Live check means, do you want to check the links is there or not? Many times their links is broken and they haven't removed, Some of the data sources that I use for understanding the links is Google Search Console. So maybe it's broken and it's not there. And force refresh means that if you, by default, it's the URLSeeder use caching. So if you call second time, it reads from the cache. So when I say force refresh, means forget about that. Every time I call, make it new. You don't need to do that, but because I'm presenting to you, that's why I use this one, but keep it false. And max concurrent crawl, come on, 5 is very low. Let's say 500, because we're not really doing crawling. Max concurrent crawl. I think I mistake something, but anyway, we'll see. Let's see where I'm using this. Oh no, that should be 5. Okay, so we're gonna keep it 5. And the timeout, it's basically page timeout. And headless, yeah, it's headless. And output directory when the research result is down, where you want to save it, and the WordPress. So look at this. This is not a part of Crawl4ai. I want to just clear this. Don't go tomorrow and use this. You think that this is just like someone, not me, a clone of me in another universe, in parallel universes, creating a research assistant using Crawl4ai, and he decided to create his own configuration file. So I just want to make it clear. This is about the app, the research assistants we created here. And then we do have this research query, which has the original query and then the enhanced query. And then we have search patterns. Search patterns are those bloat patterns that you want to cross-check over the URL. For example, you're looking for all those URLs that they have doc in them, or they have about, or they have a sport in them. So you can pass that one to have another level of filtering. And we have finally research results. Research results has the query, the discovered URLs, the crawled contents, the synthesized text, the last one, citations, and metadata, information is about the number of the links, the times, and that kind of thing that for the research. Or maybe you can add, for example, use token. So that's it. I create one simple research config and I print it. So right now, this is the research config. So again, remember, this is the kind of research level. Maybe one day I because I have a very sophisticated version of this that I use it for myself. Maybe I bring that into Crawl4ai. It's not a bad idea. How would you think? Do you think the thing is kind of helpful? I don't know if it's really helpful or not to give the ability of the research to Crawl4ai, because this is something usually you're going to build with Crawl4ai. Let me know. And now we have this. Okay, so now we have the configuration. We're going to go to query enhancement. We use language model to do that. And so it's basically prompt engineering, just the way that you're going to bring your mindset to the prompt. You want to improve it. It's just a given this search query, extract key terms, related search terms, more specific enhanced version of the query, and return me a JSON like this, like that. And I'm calling light LLM a completion, a synchronous version. And I'm saying I want JSON objects and I low temperature because I want to get less randomized. The data is, I don't want to get far from that. Don't want to be too creative. So I extract it and I have all of it. And now I can create the research query. Remember the original query, the enhanced version, the search pattern. I think for this case, let me ignore the pattern. Okay, let it be there from now. Because we have to do something different for the pattern. But for now, I'll just put it empty. So then, and then we just print it, and that's all. I run the code. I already run it. So I say Premier League news, and I will get this one. So latest Premier League news update on teams, players, match results, and key terms. You see football, soccer, and all those kind of things. So I have this extended query that now I can apply this to that URL discovery. Now we are in the part that we'll see a Crawl4ai. So the rest was the research app. Now we're going to go to Crawl4ai. I'm creating these URL functions, discover URLs, domain, query, and config. So these are search query, research config. This is the new class added to Crawl4ai, async URLSeeder. So how it works is you just create, you can create an object You can call start functions, and when everything is done, call the close functions to release all the memory and everything, or use through the async context. And I'm passing my favorite logger, my own logger, async logger, and I have this seeder now. Then we create a seeding config. This is Crawl4ai config object. We have source. So there are multiple sources. We check sitemap of the website. We check common crawl, which updates every 2 weeks or 4 weeks, and it contains all the links in this planet Earth. We use Search Console, a bunch of other things. Right now, I'm saying I want sitemap, and also I want the CC, the common crawl, for example. Or I can just say I want this only sitemap. And then extract head. Extract head, remember, is the ability that when I look at these URLs, I want to extract their head information as well. So I can do that. And it can be true or it can be false. You can just, and then you can extract title, descriptions, metadata, all those kind of things. And then this is the query. The query is the query you're getting from the user. So either it's enhanced query or the original query. If the enhanced does not exist, it goes to original query. Then I have a scoring method, which is BM25. By default, it's BM25, by the way. And then the score threshold. And then we have max URLs. So that's called max URL discovery. Let's see what was the max URL discovery in our config. Max URL discovery. This is very strong. You can really go 1,000. Because the way we check is different, and I don't think you're going to face with block your IP address or anything. But anyway, put 500. And then, but the algorithm has a nice capability to support it. So, where is it? Okay. And then we're going to run it. So seeders, the function is the seeders.urls. So just get you back all the URLs. Domain and config, and then you get it. And I pick up top K, and then I have a top K, and then I add them. The relevancy scores, the title, the URLs, all these kind of things, at the end. And it's very fast. When you run this, it's just maybe a few seconds. You get all of it. And this is because I put the verbose true, that's why you can see everything. It's bringing, so the live check, because live check is true. So it's check that it exists. And check, you see, this is a sport. It doesn't have that much. Or this one has some relevancy. Oh, this one is, because it's Premier League. Yeah, interesting. So of course. And then all these kind of things. You go down. And then we find 10 links, and these are the top 5 URLs. It's extremely fast. Run it, and you will see. And then we have, finally, the part that we want to crawl. The crawling is as usual, it's just get the URLs, you define your markdown generator, your crawler run config, and then async the crawler. So I assume you have seen my other videos. And then here we call a run many, and then I pass all the URLs. So you see that there is a comparison you can make between this and deep crawling. Deep crawling uses BFS or BFF or DFS algorithms to dive into the websites, go deep and string for you. Here, we get the list of URLs you want to do that. So we don't need to go to deep crawling. So that's a benefit that has this benefit. But the thing is that there are links that there's a possibility that sometimes there are links, dynamic links especially, that you can't get them on URLSeeder, because URLSeeder needs the link to be registered. But those links that you have to click, you have to open dynamically, all those kind of things come from a deep crawl. But anyway, you have to think which one works for you. So just go for the one that is better. So where we are. So we are here, and now we call a run many, and then boom, and then we got the results, and iterate through the results, and yeah, all crawled. So we got, I think, 5 of them, because we had the top 5. So we got the crawling, and you have all the information. It's saved to that blue color. Maybe I have to create a Chrome extension to change the color of the links in Colab. Maybe you do. Right now, no, we got all the data, right? We have all the data. I think it's, excuse me. If you run it, you will see the file here. So now we go with finally generated research. This is just simple. It doesn't have anything with me. We pass the research query, crawl contents and configuration. And then I have this. Now I'll iterate through the crawl content. I convert every crawl contents into a piece of text that I want to inject to my prompt. So here you can see the section I, title, URL, the content preview. So it's the content. And I just picked up the 5,000, the first 1,500 characters. But in your projects, you can take all of it. Just do all of it. I was assuming that all these articles in the first or second paragraph, they give an abstract of what they have. I prefer to do that. Or let's say put the content. Better to do that. Okay. So, and then we're going to add it, and I have this separation between them. Finally, come to my a completion function. And this is the research query based on the following sources, provide comprehensive, and I'm going to write that resources. So I like to have the XML tag. Please provide this and that, whatever you want. It's just your choice. And less than 800, and I put a little bit more creativity in it. Maybe we can go even above 1. And I said do the citation, so that's important. So we get the synthesized response out of it, and then and I will extract all the citations from the URLs, and now I have citations and I have synthesizers. This is from the crowd results, and I print the first 500. So this is the research results. The recent transfer news in Premier League highlighted significant player movements, the strategy decisions at the top. Arsenal. Oh, Arsenal. Okay, so you're and then in the next part, okay, so that's it. You just got the result. Do whatever you wanted, right? And I just combine everything into one research pipeline. It's easy to see the whole thing. So what it does is get the query and get the config, start, and if you run it, you will see those colorful terminal text messages. And then you get first enhanced query, and you build your research query, and then we do the discovery URLs. Then we do the crawlings, and in the next step, we synthesize and search results. And finally, we save it, just create and close and print. And yeah, that's what we got it. So we got the whole information here, and research is ready, discovered, and this and that. And also I created a kind of helper function that get the research result and then convert it for you like a research. So it's a markdown, and then you can save it and have the score. So in this, and so that is the whole thing. This is another helper function that will just save into a JSON and markdown for you. These are just options to just skip it and to see how it goes. And also I put everything to each other. It's like a kind of interactive. You can run it on your terminal, and it asks you questions. For example, tell you that how much depth you want to go for your research. Basically, depth here defined by the number of the URLs you want to go that. But this is a kind of, a kind of horizontal. You increase horizontally when you want to get more URL. But how you want to go deep in them is a different scenario. So anyway, there are different ways to think about it. That's just, I'll leave it to you, but the concept is the same. And I already created some tips for you that how to use URLSeeder in a better way, performance tips, and caching. Cache is really good. You don't need to repeat that one. And finally, I'm talking about the agentic design pattern. So this was a simple pattern that I created for you, but you can really create different patterns like the one that I have here. So what it does is it basically, it generate multiple, it get the query, it generate multiple query for you, multiple queries. So now for each one of those query, it does parallel URL filtering, and then get all of them, aggregate, and crawl all of them. And then we check that if this information is enough, reflection. If not, we go back to B again. So we just regenerate, repeat this one. If everything is good, we synthesize. So this is like another pattern of the building agentic pipeline. So it's your choice to how you're going to do that. So that's it, everyone. So this was a brief introduction to URLSeeder and building your research agent with this, and you can do a lot of crazy stuff. So I really suggest you to do that. It's fun. It's fun, really. And I am going to drop some more tutorials soon about extracting more structured data from some pages like LinkedIn's and other stuffs, identity aware crawlings, and many more actually. So stay tuned. Join the Discord channels. Come to the Discord. Discord is fun. You can ask your questions. Let's start the repository. We just hit. Let's see where we are. Perfectos. We are 45,000. That's beautiful. Very beautiful. I'm very happy with that. 4.24. This is so beautiful. It means you built something that people built top of that, and you are immortal somehow, right? Okay, thank you so much, everybody. Love you all. And Uncle Code out.